All right, folks, take your seats. We're going to get started. Sorry, technical difficulties. All right. Well, thank you, everyone, for coming. I hope you guys got more caffeine during the break and got a chance to talk with our exhibitors. So this is special session number 6, AAM, eVTOL, and Rotorcraft, and helicopter piloting collaboration. I've got a great set of speakers today. I'm Mike Hirschberg. For those of you who don't know, I was the director of the Vertical Flight Society from 2011 to 2023, and it's a real honor for me to be able to help out and moderate this session. Here are our esteemed speakers. So we've got government, FAA, we've got industry for Rotorcraft, and 2 eVTOL companies, autonomous and piloted, and we're going to have a great discussion. Each of the presenters will come up and talk for 15-20 minutes, and then at the end we'll have a discussion at the end. I've got a couple questions, not many, so I'm opening up to the audience. So don't be shy. Just remember we've got a microphone up here and then one back there, so all the questions have to go in the microphone. We have a great session comprised of some really fantastic speakers, good friends to me and to Vertical Flight Society, and really dedicated to advancing vertical flight. I should also mention that for Leonardo, in addition to the speaker we have here, we also have Dr. Emanuela Bianchi, who will also be speaking on some of the work that they've done. So first off is Cliff Johnson, who serves as a research engineer, program manager, and technical lead at the FAA's William J. Hughes Technical Center in Atlantic City, New Jersey. He's got over 17 years of experience with the FAA, and he's overseen numerous research and development projects focused on rotorcraft, vertical flight, and unmanned aircraft systems. These projects aim to enhance aviation safety through applied research via manned and unmanned aircraft, rotorcraft simulations, and live flight tests as a test director, pilot, and flight test engineer. He's a licensed instrument-rated commercial pilot, both helicopter and airplane. Just added one of those last week. He's also a UAS pilot, and he's currently pursuing additional pilot rating. So, Cliff, come on up. And he's a government guy, so you can applaud if you'd like.
Hi, everybody. You can boo also if you want. I'm from Philly, so we're used to that, you know. All right. Well, it's a pleasure to be here, as Keith Richards always says, right? Happy to be here, happy to be anywhere, but very happy to be back here addressing all of you fine folks at Vertical Flight Society at Forum 82. I'm going to talk about a perspective of our current FAA vertical flight research and development here, and just kind of give you an overview of some of the things that we're doing with an eye towards collaboration. Everything we do is collaborative. We cannot do anything on our own. We're the FAA. We are ultimately the folks that are the Civil Aviation Authority that are responsible for implementing things. And we don't do that without partnerships with industry, academia, other government agencies. And I'm proud to say that we do that with not just our national and domestic partners here in the U.S., but internationally with our friends around the world. So I'll go over a little bit of our projects, our partnerships, all of our motivation here. Why are we doing this? I want to talk a little bit about some of the collaborative areas that we have. I'll give you just a smattering of our capabilities at the FAA, at the William J. Hughes Technical Center for Advanced Aerospace. specifically surrounding vertical flight. If you've never been, it's in Atlantic City, New Jersey. It's getting to be a great time of year to come visit. We would love to have you and host you for some of the stuff that we're doing and talk about where we're going, why we're doing what we're doing in terms of the research outcomes and the impact. And then we'll take questions at the end. So the FAA, our vertical flight safety research program, we predominantly do vertical flight safety research, and that's not just legacy traditional rotorcraft, but we've moved into the powered lift AAM domain, as well as other things that we've done on unmanned aircraft and everything. But everything we do is really centered around that future vision of a future with zero accidents. And myself and my team, we primarily look at technologies. So we have a vertical flight aviation simulation technologies laboratory where we look at potential safety enhancements for helicopters, working with the safety teams like the United States Helicopter Safety Team, the Vertical Aviation Safety Team, a lot of the VFS working groups. And we do all that with the eye towards the future, saying that we test the technologies of tomorrow today. I know that's a little Disney-esque, but it's really the truth. It's really what we do. This is a roadmap of sort of the research activities that we are working on within the FAA, and kind of primarily a little bit of history of some of the stuff that we've done here, recent history of where we've started, plan to where we are going, what we do now, where we're going in the future. A lot of our research work, at least since I've been involved, has been focused on some of the legacy things, moving things over from the fixed wing community, such as flight data monitoring, vision systems technology, things in degraded visual environments, vertiports. Obviously, as we move forward, we'll talk a little bit about it, but those of you that were around, we did some studies both in the simulator as well as in real life, working with the Office of Airports to come up with what some of the standards and the criteria were going to be for the engineering brief EB 105 that the FAA put out. And sometimes when you do some of that testing, you find that sometimes there's changes you don't want to make. And that's just as an important thing versus things that you do. So that kind of moved into kind of the near-term phase that I would say, where we're sort of at right now, where we're looking at more of the virtual reality flight simulation training devices, still doing some work on some of those other things, but starting to get into the areas of, more IFR infrastructure, so procedures. We're looking at things like IFR to the surface, as well as other things we continue to look at, reducing loss of control accidents. How do we do that with better automated flight control systems, better technologies of looking at flight regimes and different things. And that kind of moves us more into kind of the future state where we look at more certified technologies, navigation, GPS denied environments, other safety enhancing devices that we don't think of yet, using more AI and machine learning type of approaches for maybe non-deterministic safety critical systems, but more technologies to help and assist the pilot in the flight deck. Here's another way to look at this, just kind of a sense of current and some legacy projects that we've been looking at primarily. In addition to the ones that I talked about before, we've also been active on looking at wire strike avoidance, integrated flight and propulsion control, things of that nature, as well as all the virtual reality and other things that we have going on, flight data monitoring, some of the other things I've talked about, like the crash-worthy fuel tanks and other things that we have going on at the center as well. All right. On the AAM side, some of the things that we've been looking at are relative to kind of the legacy helicopter, but they've also been looking at things like downwash and outwash. We've started to get into looking at things on that, landing accuracy, sorry for the, the back and forth there, some of the icing aspects, and then some of the aircraft rescue and firefighting, and the infrastructure, which is also important. I mentioned before, we don't do this alone. We do this with a number of different partners. I apologize if I forgot somebody and you're not on the slide. It's not intentional. I am a racing fan, so those that know me know that I like NASCAR, IndyCar, right? So I like and Formula One as well. And I'm a Ferrari fan for my friends from Italy. got to get our act together in the pits here, but recently on these races. But anyway, so a lot of different logos on here. The point being is that we work with everybody, and we'd love to work with you if you're not on here. We are the kinder, gentler form of the FAA, if you will. So anyway, all right, next one. I want to talk briefly a little bit about this. I'm sure my colleagues on the panel will probably hit on this a little bit more than I will. But the FAA recently announced an enhanced integration pilot program for eVTOLs, and there were 8 sites selected. There's a number of different sites, partnerships. You can go on the FAA's website as well as the DOT's website as well. There's more information on here about the EIPPs. They're just standing up. We've done a number of different partnership programs in the past, dating back to the stuff we've done with the test sites and others as well. So there is kind of a long legacy of that public-private partnership and collaboration. I think this just extends it and it operationalizes it as we look towards initial operating capability and the start of commercial operations with some of these platforms. So motivation, why do we do what we do? Well, number one, like anything else, I fly, I have friends that fly, I work with a lot of people in the industry. Anytime there's an accident, it's bad for everyone, right? And there are things that we can do to prevent that. So historically, we're trying to prevent helicopter fatal accidents, reducing the fatal accident rate for rotorcraft. This also extends out, when we get, some of the new entrants flying. We don't want to have accidents there as well. We want to continue to reduce the commercial fatal accident rate. So that's one thing. And the top 3 historically have been loss of control, unintended instrument flight into meteorological conditions, or low altitude operations. But there's a whole host of other things. The other motivator of why we do what we do is really to look at the pilot shortage. So yes, there is a pilot shortage, and yes, it goes in waves with hiring by the airlines and different things. So people come in and they go, and everybody focuses on that. But a lot of times, where are we pulling, our pilots from? It's not just from the airlines, right? It's from people that are already flying on the helicopter side, or that may be thinking about going into the piloted version of the new platforms until we get to some of the ones that are going to be unmanned or autonomous or remotely piloted. Where are we getting these people from? That's a huge concern and something that I think we are looking at within the industry. So it's a question of how do we go and address that, because they have to come from somewhere, and if we're taking them from certain places, what are our pipelines like? How do we improve that? How do we motivate more people to go into this industry? It all plays a role. And then once we've got people that want to fly, how do we enhance the efficiency of the training? I started out myself on unmanned aircraft first. I learned some of the basics of flying through ground schools and different things and flying that. And then I got, my instructor told me, hey, let's go fly. Let's take you up in a Cessna 172. And, I grew up video game generation. I played X-Plane, Microsoft Flight Simulator. I thought I knew what I was doing. Got in the aircraft. I didn't know what I was doing. It was completely not what I expected, but it was a great learning experience. But there are certainly, as I look back on my flight training, there are certainly, times that it was not efficient for various reasons. And I learned things, but could I have learned things a little bit better in a different environment? I think we're getting to the point now where simulation really can help. And I think myself and another one of my colleagues, a plug for her work, which I'll talk about later on, and she has a couple presentations and papers here at the forum that we've wrote together. I think that's paving the way, and I think that is a path as we go forward. So as I talk about some of the areas, I'm not going to hit on everything. I gave kind of the overview slides of some of the things, but some of the things that I'd like to just highlight a little bit more of things that we are doing. And these are specific areas where we have actual agreements. We're working in this space with some partners of ours already. We'd obviously love to do more with all of you as we go forward. So the first one is really instrument flight procedures, IFR to the surface. And our colleagues over here with Wisk, David's going to be up here talking about this soon. We have a cooperative research and development agreement. You'll hear that term a number of times. It's just an agreement where we partner with someone from, could be industry, could be academia, and we agree to share resources towards resolving a joint problem that we're trying to do, we're trying to look at in research. And in this case, what we're trying to do is look at how do we enable instrument flight procedures for powered lift, AAM, eVTOL, both on the piloted side as well as autonomous as we get to that point. And the idea behind this is how do we take, for those that are helicopter pilots, if you're familiar with point in space approaches, how do we get beyond what we do today for point in space approaches and departures and go all the way to the surface? So think of like a Cat 3 ILS type of an approach to a runway and everything that's involved in that, or a GBAS approach, something like that, GLS approach. How do we get to that for vertical flight? And how do we do that going to, a vertiport, heliport, spot, at the FBO, different things. There's a lot there, and I don't know how far we will ultimately get, but our goal is to get as close to that as we possibly can. We don't know if we don't try. So we're trying to evolve it. Technology's getting better. We're really seriously looking at this to change some of the guidance within the FAA. We also have done a number of modeling and simulation activities using assets at the FAA William J. Hughes Technical Center. This is kind of an overview slide of, if you see it over, you can see it on both sides here, just of all the different assets that we have here at the center, and it's really focused on how do we kind of advance the air traffic piece of this. So we talk a lot about the vehicle side. I do a lot of work on that side, but how do we come up with the procedures and things for air traffic to handle these platforms? And for this, we've actually partnered with both our friends at Wisk as well as our Ryan, and he's going to talk a little bit about some of the stuff. We have a CRADA that was signed with Joby. We have a Joby simulator at the FAA that is part of this. We run different airspace configurations. We have modeled traffic, and then we also have some piloted and some autonomous traffic in there as well. And we're all working towards how do we move forward with this. And this gives you a little bit of an overview. This is from a little while back, a couple years ago, when we were doing the work with NASA with some of their flyers. We had tied in NASA's Langley Research Center to our environment, and that's part of our capability. We can do live, virtual, and constructive testing, and we can integrate partners from around the world for this. This is a display just showing of the AAM traffic that we have here on the STARS display. So we do all that. Beyond that, we also have been looking at extended reality, so flight deck training. So I'll talk a little bit about what we're doing with more of the motion-based simulators, but we also look at things where we're looking at extended reality headsets, not just for the pilot qualification of getting a rating or adding a rating on or doing different things, but how do we start coming up with guidance for flight deck trainers and things of that nature. So this is a picture of CAE. They announced what they were doing with their Apple Vision Pro. We have one of their Apple Vision Pros at the FAA. It's really phenomenal. You can sit in the cockpit, you look at the entire flight deck, and you train on it as if you were in an FTD. So it's a procedures trainer. Other OEMs and other simulator companies are doing similar things. How do we get that technology, and evolve that to, be able to, secure some credit for doing that work? That's part of our research effort as well. It's not just on the helicopter community, it's also making its way into the fixed wing community as well. We also have a CRADA with Acme, Acme Worldwide Enterprises as well. They are a dynamic motion seat company, and we're working with them to look at, okay, is there potential for coming up with some qualification surrounding seat dynamics rather than the motion of the base of the simulator itself. They have a number of different systems around the world, primarily on the military side. we're looking to see if we can look at incorporating some of that into our qualification standards and guidance as we update that for more of these immersive technologies. So that brings me to one of the bigger ones that we've done, which is we've not just looking at flight deck and procedures trainers, but how do we actually enhance pilot training with virtual reality flight simulation? So this is, a slide. There are 3 companies in the world today. I should say, let me back that up. It's within the U.S. There are different qualification standards from EASA, but Loft Dynamics, True Simulation, and our friends here at Leonardo, they all have, within the past 2 years, have acquired level 7 qualification from the FAA on their virtual reality flight devices. Loft's the H125, True's Bell 505, and Leonardo's AW119. We were involved in some aspects of all the qualification of each devices, either at the qualification events or events leading up to them. And my team helped, the simulation engineers within the FAA understand what virtual reality is, how do we look at different things, and everything. And what we're trying to do is that, the reason this is important is that the newer devices they're more affordable, they're more accessible, they're more compact, they're more immersive than your legacy devices, and we all know that. We've qualified these ones, I just mentioned that, with a new generation, and they have reduced motion platforms as well. Additionally, if more flight programs adopt them, it could solve the pilot training shortage that I mentioned earlier. But, there's always a but, right? How effective are these devices really in training pilots to meet airman certification standards, the ACS that we have within the FAA? So therefore, what we did is we partnered last year with Marshall University and Loft Dynamics, and we executed a study, and if you want to find out more details of this, I highly encourage you to, I don't want you to leave this session, but we have 2 papers that are being presented by a colleague of mine, Dr. Eleni Soteropoulos, and this is going to talk about the FAA VR HeliStart project here at the forum. They're both in the modeling sim session, I think. You can look them up on your schedule. One is this afternoon on the hovering maneuvers, the other one later on this morning, which covers the overview, methodology, and overall results. But we did this whole study with a group of folks, and we took the students through simulation, and then we put them in the actual helicopter for a few flights for their stage checks. And we evaluated the work that they had done, what was their skill level in terms of meeting ACS standards for commercial helicopter pilots, both in the simulator as well as in the actual helicopter as well. So all that said, that's kind of the projects that we're doing. I want to just spend a moment here and talk about some of our laboratory capabilities towards here, and all of these have been done really with the collaboration and the partnership that we have. So I won't talk about everything, but some of the things that I mentioned before for the modeling and sim that we're doing for AAM at the center involves our target generation facility and our cockpit simulation facility. We have a number of simulators at the FAA, everything from transport category fixed wing to general aviation platforms to rotorcraft to some VTOL powered lift and unmanned aircraft simulators as well. But for the purposes of the conversation here today, I'm going to talk on 2 things, one being the Vertical Flight Aviation Simulation Technologies, or VFAST, laboratory that we have, and our research vertiport. Our laboratory here, as you can see, if I can get this to work, it has a number of different simulators. I've talked about some of them as well. We have some fixed base, some mini motion based simulators. We don't have a level D platform or anything, but we have visual systems. It's all live, virtual, and constructive. The software, hardware, graphics, everything is developed and maintained by our team. As far as flight simulators go right now, we do have the following. We have a Bell 407, a few of the Loft simulators, 125, R22, and our S76D simulator as well. And we've been putting together a Cabri, a Gimbal G2 to follow on the one that myself and some of my colleagues have been going through on our flight training. So, and then we also have, some VTOL platforms as well that I mentioned. We do have a research vertiport, originally a research heliport. It's one of only 5 that I'm aware of in the world that have the capability to do the instrument criteria as it exists today. And we are looking at modifying that criteria. But what I mean by that is we have the precision approach lighting system here, the HALS, the helicopter heliport approach, light system. We have the PAPIs, CHAPIs, different things out there. And we've done a number of test operations there to that vertiport. It's all instrumented with weather platforms, weather sensors, an RVR sensor. It has cameras out there, different things. And I've used it historically for a lot of my vertical flight research when we've done flight testing on vision systems or flight data monitoring or, pick a project that we've done. So that is there. So where's this all going? What are we trying to accomplish here? I want to talk a little bit just about the research outcomes and the impacts and why we're doing is important. Why are we doing what we are doing? I will say that on the pilot training side, there is definitely room for updates to Part 61, as well as the FAA announced a modernization effort of Part 141, and some of that is geared towards looking at giving more examining authority to some of the schools. But that also has a part to play with our research, which is how do we start incorporating more of these, newer, next generation technology of virtual reality type platforms into a 141 training program? How do we provide for additional credit? It's one thing to get the device qualified. It's another thing to be able to use it and to be able to say, hey, I'm going to do X number of hours on the platform. It also looks at, as we come up with new things, either through the powered lift SFAR or through the work that we're doing right now, how do we update the ACS? What has to be done? The helicopter flying handbook. If you read the flying handbook, and I know this having just gone through my helicopter training as well, there's some sections that are kind of confusing, that are in conflict with one another. We could do a little bit better, and we will do better. So how do we update that? How do we get more of the infrastructure piece on there that Rex and I always talk about? How do we try to incorporate, the signage, the markings, all those different things that, when I ask some of my instructors, they don't know about that, and they're not teaching that. How do we get that into the platform is something we're looking at. And then, again, some of the safety enhancements that we've done through the helicopter safety team and the VAST, how do we promulgate that to the international community, and how do we build on that? So it really is about going from research to making it real. Everybody talks about return on investment in the environment that we're in today. These are the things that are the real things that we're trying to come up with and that the research is pointing towards. How do we reduce the cost and time to train to proficiency? How do we evolve the technology? How do we expand what we did on the helicopter study to future vertical lift, whether it's through powered lift, unmanned aircraft, autonomous stuff, different things. How do we do that? How do we make that meaningful? And that takes not just the FAA and what we're doing, but that takes the entire community as well. So, and then as I mentioned, can we evolve it so it's not pure qualification of devices to prescriptive standards? How do we go to more performance-based? How do we look at competency-based learning and other types of things? Again, just another little shameless plug for our work, but was really good issue of the FAA Safety Briefing magazine. This is online. There were some hard copies available at Verticon if anyone grabbed them, but there was a number of really good safety articles on there about the work that the FAA and others are doing within the community, and I was honored that they actually reached out to us and wrote an article on the project that we were doing, which is a virtual approach to the real futures, name of the article, and it talks about what we are doing on the flight simulation piece of the virtual reality. Again, more detail. You can talk to me. I encourage you to see, Elaine's presentations. However, there's also an article if you want the Cliff's Notes version of it, but not from Cliff. So with that said, that's all I had. I appreciate it, and I'll turn it back over to Mike, and we'll go to the next speaker and take questions at the end.
So there was a lot of depth in there, so I hope you took notes, because we will have the opportunity, and you are requested to ask questions of the speakers. So our next speaker, my computer keeps locking on me every couple seconds. So our next speaker is Matteo Ragazzi from Leonardo Helicopter Division, where he's the Senior Vice President for Engineering and Innovation. After his, when he started with Leonardo, after an initial period in the drive system department, he became the Chief Project Engineer for the AW139 and then the AW189. He then took the role of Head of Airworthiness and the EASA Design Organization Approval, DOA. In 2019, he took on the role of Head of Engineering, which is expanded in 2022 to include the Technology and Innovation function. And as mentioned previously, he's going to talk for a while and have Dr. Bianchi come up as well. You can clap for him too.
Hello, and well, nice that Cliff was introducing all these things. He's been doing tons of things. I don't know. You didn't leave any space for anybody else, you know. Okay, very interesting. From what concerns us, let's say that the problem we were trying to solve was stemming from a lot of scars on our backs. Let's be honest, you know, that we are OEMs. So some time ago, think about early 20s, we were starting playing with advanced air mobility. And since we're not shy to say that we are also tiltrotors fans, we were doing also, as we're doing today, 609. So we were tackling new architectures, a new way of transportation, and so forth. So what happened was that we started studying solutions, and we were very curious about the art of the possible at that time. So you start with batteries and so on, and we were following closely the pace of our friends like Joby, Wisk, and so forth. But there was a problem there. The problem was that we realized soon that the success of those things will depend upon some key factors that we need to help, if you want, to create. It's like designing a car without understanding if it's actually you're going to get a steering wheel and the power on the right and the brakes on the left. Well, today when we rent a car, we know where it is, you know. But the other thing was, okay, what is the side of the road we need to drive, you know, which is the code. And so there was actually big stuff like that was puzzling us pretty much. The other thing was that we made up some numbers, and we realized that the target population would be to create a generation of pilots. Now, Cliff was pointing out to pilot shortage. Now, imagine that you need to create a generation of pilots that is able to work in advanced air mobility that is some order of magnitudes above what is our known helicopter population or vertical flight helicopter population. Because we're talking about mass transportation, not aviation. So it's mass transportation by air. So clearly the intent will be probably what some of our friends are doing, that is get a pilot out of the cockpit sooner or later. But it's not going to be a quick thing. So in our approach, we simply were taking one example. If you go to Milan, the city we are based, you got taxi drivers with licenses. You got, if you want, bus drivers. In a city like Milan, there are already thousands. Okay. Now, I don't want to get there, but certainly if you add up the cities where you need to create volumes of mass transportation, the numbers will be serious, okay? So you need to create a recipe to get there, right? Now, if you look at the experiences we have in aviation today, we don't have such a great reputation, frankly. So the most successful example is, if you think about airliners, you got Airbus and Boeing and so on, just to give you an idea. Many people flying there, these vehicles, but no standards, frankly, not enough standards. So, okay, as a solution, but how costly it is to basically get the currency, to get the transition from one to another. And by the way, that applies also to our helicopters when we need to move from one type to another type. So the problem is not okay today. And the solutions that has been provided by industry are not serving the cause of big volumes, to be frank. And the cost proposition that Cliff was hinting at is there. It's too costly, okay? Another not exactly success story is what we went through with 609. So it's obvious that we are head down to do the certification with the FAA at the moment, but the licensing has been a pain. The first approach was, if you want to become a tilt-rotor pilot, you need to come from V22, okay? Maybe something better. So then it's been this far and so on. But if you like, it's a first cut this far to this problem. To be frank, okay for the first, but not okay for volumes, because as a matter of fact, it's the sum of two vehicles. It's not exactly the recipe. We're talking about vehicles that are different from each other, that require enhanced, if you want a vehicle to help the piloting. You're not going to direct piloting on these vehicles, not even on the 609 if you like, but even more on the AAM. You need standards that don't require the level of skills of a pilot from airplanes and helicopters combined together. Otherwise, the result will be unaffordable. If you think about 50 flight hours to get to a license, okay, it's not going to be working out very well. So that's why we were simply saying, in this case, we have the luxury of not being competitors or OEMs in the AAM. So why don't we help the community? And the intent was to help the community, exactly as Cliff does with FAA at the moment. We were basically doing the same approach. So we gave a first cut on what could we offer as a way to get to a standard for piloting. That was our intent. So it's obvious that as an OEM, we see multiple areas of advantage. But think that this time, we're not talking in the interest of Leonardo. We're talking about in the interest of the community to create a new, if you want, a paradigm and new kind of means of transportation. And we have in mass transportation wired in our brain, okay? That's the intent. So the point we were trying to make was how can we help in creating something like that? So we went with methods. We gave a first cut on how we do it. So the whole thing was on the how, okay? So that's when the moment I passed the ball to Emanuele Bianchi. Imagine that we have within Leonardo a group of people that is doing preliminary design, general architecture, and HMI. And this is when basically we wanted to have a group of people led by Emanuele's team to basically give their idea on a first cut and call the others to participate. So we're happy that there was a good response, and I'm happy that also Joby was coming to visit us. But the intent is to help the community. That's what it is. So I pass the ball to Emanuele.
Okay, thank you, Matteo. Hello, everyone. And I'm here to present some results and to explain what we did in the last year with the collaboration within the EuroCAE framework WG112 in order to create and analyze a potential, let's say, comparison between different piloting configuration in terms of insight of HMI architecture, and in order to assess which are the most useful for the purpose of operating urban air mobility aircraft. Of course, this opportunity was done within a community, a large community of authority, driven by, leading by EASA, but with the collaboration also of FAA, EuroCAE, and many other teams that were accepted to be part of the team in active way, so offering help in this evaluation, or at least a part of the team in terms of interest and analyzing the results that we found. And basically, the objective of the evaluation was really to understand which, within a bunch of 5 different configurations, was the most useful and the most fitting for purpose configuration. And this selection was done through, of course, a selection with EuroCAE within, of course, solutions that are already part of some of the aircraft that still fly in this moment, and also other potential, let's say, candidates, in order to compare these in the same environment, in order to find a fair way to compare those. And this was basically the main problem, how to find a way to create this kind of evaluation in the best way possible. And this is why we create what we call evaluation framework, that is more than a tool, is a structured way, a structured human-centered approach that support the system development and the analysis, particularly in this critical, safety-critical context. Basically, everything was based on a specific test structure and a specific test protocol that involve pilots and other non-pilots, but specialists in this field, in this evaluation. And everything was done in order to track, basically, the development, and also to ensure the measurability of the data, and to support a decision-making and to offer a different way to collect data and analyze the results. Here you can see the 5 configurations that we used, and this is the test structure that we organized. So there was basically a simulator that we will show you later that was offered as a bench for this test. But the core is really the test structure that was based on an initial briefing and a configuration introduction for each participant, and then the execution of a test card or a familiarization for each of those configurations. During those test card execution or familiarization, many data were collected, both subjective and objective, based on the evaluation framework that we will see in a minute. Then interviews were performed at the end of each test for each pilot in order to collect specific information about the configuration that was tested, and then a comparative debrief was asked to the pilot at the end of the entire cycle in order to create a kind of score table for each of the configuration. Consider that the test protocol was really the focus, the main focus of the research, because we try to apply a human-centered approach and try to be impartial and to filter any kind of external factor that could, let's say, lead to solution to, let's say, results that were not fully pertinent. So we, with this test protocol, basically, the test card was decided together with the team and the Aerocae in order to select a series of test points that were applicable to a typical mission within a city that was Milan in this case. And the test card was contained many maneuvers that were again selected with the pilot and considered pertinent for the mission, and also with a specific target and for the time to operate within that mission, and also the results. And during this, the test itself was done on a low fidelity simulation, basic on kinematic flight mechanic simulator with the help of virtual reality that was basically create the scenario based used for the pilot to make the assessment. This is the setup that the test protocol that we follow, and basically the test card, this is one of the example. You can also see the typical 7 maneuver that we asked to perform to the pilot for each configuration. There are the setup was really the core of the research. There was a team composed by a test conductor, some observer, and 3 technicians in order to collect all the data for each pilot. There was a setup, an hardware setup based with this kinematic simulator. And there were many data collectors that allow to collect video, microphone, and also the telemetry of each of the real flight tests performed on the simulator. We collect 83 hours, about 83 hours of video, plus 45 gigabytes of data that was, of course, analyzed together with all the other tests that we perform with the data collection. Data collection was basically based on 3 main kind of data. The first one is the subjective quantitative data that are basically for each maneuver asking to the pilot to create, compile a Bedford scale and a Cooper-Harper scale. And then for each configuration to answer to an easy of use scale and other scale like adequacy, intuitiveness, and system usability. Those numbers were, of course, recorded by our note taker. And then the second bunch of data was basically the subjective qualitative data that are mainly for each maneuver the think aloud approach, asking to the pilot to create and to make comment on that was registered and then analyzed, and also to express reasoning for any issue at the end of each maneuver. Finally, there was a bunch of data that is the objective quantitative data, and those come from basically the telemetry that create all these giga data that was analyzed. With these three data, we were able to respond to the what, why, how answer for each configuration and to compare the results. We can make this. Was a simulation recorder that show you, for example, a final approach in Linate Airport. The pilot were able to see in front of him the scenario with the virtual reality, operating the different configuration of side stick, and also offering a common interface for the PFD that you can see on the left. In this case, you can appreciate, for example, some movement and difficulties in the approach, also because we were able to introduce, in some case, wind or other kind of, let's say, additional input in order to complicate a little bit and to stress a little bit the pilot in order to get really more the difference between the different configuration. Let's say, what are the results? I want to anticipate that the results, of course, are mainly dependent also to the statistics and to many other factors. And so, in this case, we have the opportunity to test 12 pilots. So the statistic number is not huge. We can only have a kind of initial trend, initial analysis of the results, and not taken as final results, absolutely. But what we really appreciate is that overall the results were consistent across the different type of data collected, showing basically ETA as the most balanced configuration within all the tested configuration. All the bunch of data, qualitative, subjective, quantitative, subjective, and objective quantitative, arrive to the same conclusion. In this case, for example, you can see the subjective quantitative results that highlight that the pilot preference are in this case ETA. And in this case, we have both fixed and rotor background of pilots that converge to the same solution. And also, we are not depending this preference to the previous experience on similar platform. And therefore, there is another aspect that was not influenced. The results was highlighted in this case. I think the other important analysis in the subjective quantitative analysis was, of course, to understand the different scale of the easy of use, appropriateness, and intuitiveness. And in all the case, you can see that data received the better score, even if in terms of absolute value, is not the best, is not something that we could say accept, let's say, optimal. For sure, there might be improvement that we can apply, because overall the number is not at a very high level as you would like to receive as a score. The other analysis based on the subjective quantitative, so the Bedford scale and the Cooper scale, again, have similar trend, where ETA was the best or the second best for each of these evaluation. And in this, let's say, radar plot, you can see that more or less the ETA curve is always at the maximum of each score for each axis, and therefore for each maneuver. The subjective qualitative were also very important to analyze because in this case you can collect important feedback from the pilots that give you hint about insight about the HMI aspects. In this case, there was some, for example, highlighting some ergonomic issue due to the twist of the wrist or to other problem in controlling the vertical speed in some case, so or unwanted coupling in some other case. So also these were recorded and part of the evaluation. And finally, the analysis of the data that was done, of course, as a post-process by our team highlighted that also the performance recorded by the simulator was in agreement with the evaluation that the pilot gave us. And therefore, we have a good consistency between telemetry and real and data that we collected by the pilot itself. We, of course, at the end of this research, we also found that there is some limitation and some step forward that we need to introduce. For example, there is a high variability and no uniform consensus due to the sample limitation. This was for sure a big problem. The statistic can only be a descriptive statistic and not a real statistics. And there is for sure some influence of previous experience, even if we try to have filter these. There is for sure a problem related to the hardware heterogeneity. We were use gaming side stick and not really sophisticated hardware that somehow can have an impact on the evaluation, and also the sample limitation. The statistic was another problem. I think also we had the test matrix, the test card was very long for each pilot. We asked about 7 hours of continuous test, so it was really very stressful for the pilot to perform the entire test card, and therefore also that can, in some case, influence the data, even if we use the randomization of the test procedure in order to not have any kind of fatigue or order effect for each pilot. There is, of course, a possible step forward, way forward that we foreseen. We need to refine the methodology that for sure is a very good initial, let's say, attempt, but can be improved. We would like to expand the sample because we definitely recognize the importance to having more pilots involved in this analysis. And also, we are looking to high fidelity test that can help in some case to collect better data, even if we still consider an important aspect of this research to use a very basic system without a full representative simulator, also because we are in a phase where it's probably not worth to have too much complicated system. In this phase, we can still deal with medium fidelity or testing in some case. And so, as Matteo was mentioned, Leonardo is calling for, let's say, a pilot standard phase 2, fostering the collaboration within the industry, because for the future share of this knowledge and resources, we will really appreciate the work done with Polytechnic of Milan, Vertical, Joby, Embraer, and also with the collaboration FAA and all the other partners, and we foster this further collaboration for the future. Thank you very much.
All right, moving right along, David Oord is the Director of Policy, Regular Affairs, and Standards at Wisk, where he leads the development and execution of strategies to shape legislation, regulations, standards, and other policies focused on autonomy and its safe integration to the national aerospace system. An active pilot, David holds a commercial pilot license with single and multi-engine airplane land and instrument ratings, which I know Cliff Johnson's going to be working on those. He previously led regulatory affairs at Lilium, the AOPA, and the Experimental Aircraft Association. He also worked in airport management, operations, security, and firefighting at Westchester Airport in New York. David?
Thanks, Mike. What a fascinating time to be in aviation. Raise of hand, who's excited to see what aviation looks like in 10 years? I mean, we are on the precipice of a pretty radical change, but everything that's going on, not only advanced air mobility with eVTOLs and new propulsions coming online. I mean, last week we had Joby flying around New York City. How awesome is that? And I think with new programs coming online, we're only going to increase that. Getting these aircraft out in the NAS, it's not futuristic, it's not the Jetsons, it's here and it's now. But it's across the board. From GA, they're going to revitalize general aviation with the Mosaic rules. We're going to have new aircraft on the lower end, really taking advantage of what Light Sport kind of pioneered and move that into more sophisticated, bigger, more capable aircraft. We have supersonic coming on board, so we can traverse this world in a more faster, quieter way, more seamless. But also, the FAA is going to finalize a rule to enable BVLOS, or beyond visual line of sight operations, for our small UAS friends. And hopefully we can integrate the low altitude, the UTM space, with the space that we're going to be in with the upper atmosphere as well. I think the FAA is really leaning into it, from airspace modernization to certification. But really, we have an agency and an administration that really wants to get to yes. They want to enable innovation and technology and be the gold standard that is worldwide. And I think we have an opportunity here that's really key, and I'm excited to talk about it. So I really wanted to focus on how do we accelerate not only AAM, but autonomous AAM. So kind of walk you through some slides about Wisk, maybe. A little bit of background about Wisk, who we are. So again, my name is Dave. I head up regulatory affairs and standards and policy for Wisk in DC, working very closely with the agency, with all the agencies through and through, the White House, the Congress as well. We have a lot of partnership, a lot of strong support throughout the U.S. federal government, but also the state as well. As far as Wisk, we're about 800 employees to date, a lot of patents issued, just like our friends out there, and a lot of full flights. We have been around for a little over 15 years. A little over, just under 1,800 flights to date. Those are all full-size flights. Locations primarily in the United States. We are headquartered out of California in Mountain View, fly out of Hollister, a little bit south of San Jose, but also offices throughout the United States. We also have a good engineering hub up in Canada, up in Montreal, have a workforce in Poland doing a lot of verification and validation of software, and then Australia as well. A great team down in Asia Pacific, really looking to pioneer some of those markets for us. We are fully owned by the Boeing Company. We started out as a small stealth startup in Silicon Valley, founded by Larry Page, who co-founded Google, as you might be aware. But then we became a joint venture with Boeing. Then a few years ago, Boeing fully acquired us. So great partnership with the Boeing Company, really leverage a lot of their expertise in this field, and really kind of hopefully provide some pathways that might have some applicability to future platforms in the Boeing product. History of flight. Again, when we were a small stealth startup, we did Gen 1. That aircraft was very narrow, intended for personal transportation. It was narrow on purpose, so you can park it in your parking garage, park it at a parking stall, and then really move a person around a city. That has morphed over the years with Gen 2 and Gen 3. Gen 3, just a little fact, if you're ever in DC, stop by the Udvar-Hazy, the Smithsonian. That aircraft is in the Smithsonian Air and Space Museum, just south of Dulles. parked right next to the, right in between the space shuttle and the SR-71. That is the first, if not one of the first aircraft ever to fully transition. So it took off vertically like a helicopter. It made a full transition to wingborne flight, did a circuit around the airport, and then transitioned back to vertical flight and safely landed. Both of those, all three of those were actually piloted, but I think we quickly realized as a company, if we really want to scale and make this more about mass transportation to the point that was made earlier, we're going to go straight to autonomy. Is it the quickest path to market? No, but it's a path that we think is rooted in two things that I'll get into later. So Gen 4 really enabled that technology around autonomy. Gen 5 was just a little bit more of an advancement, and then Gen 6 is the aircraft that we are currently flying. We just flew our second aircraft, I think last week, and that flight test campaign is off and running. So great to be up in the air, great to really plowing that stream ahead. So what is Gen 6? So Gen 6, it is autonomous, but it's autonomous with human oversight. We are not getting rid of people. They are still supervising the operation just like a pilot. Most of you probably flew here shortly after takeoff. Pilot, click, click, he or she supervises the flight for the majority of the tasking and then does a little couple clicks, chirp, final, and then hand flies it down. That is not unsimilar to what we will be doing. Pilot will be in command. He or she will push a button to go. They will supervise the flight, and then if anything needs to happen, they will intervene. But they also can talk to air traffic control. They can direct the aircraft. So they're definitely over the loop supervising that. And if you look at what the FAA is doing with airspace modernization, moving the air traffic control to more of that supervisory role, I think that's a nice complement. And so we can move both of those streams in parallel. 4 seats, there is room, it does have a front trunk for those that drive electric aircraft, electric vehicles. You can put your rollerboard up front. It goes about 90 miles, which is a nice mission for urban air mobility, city transit, downtown to suburbs, airport, et cetera. But that's only going to improve over time as battery technologies improve, and so we'll get there. Why autonomy, though? A lot of people say, well, you're just going straight to autonomy because you want to get the pilots out of it. I can assure you that we will have more crew involved in our aircraft than probably a single pilot 135 operation, and that's key. We need to have that human oversight. Pilots do what they do very well. I think Cliff highlighted the Pareto chart that they did for US HST. I had the privilege to lead the first 2 working groups under the loss control working group under the General Aviation Joint Steering Committee. And if you look at the causal accidents, yeah, by far and away, 40–50% of the accidents are loss control. And then you have controlled flight into terrain, and then you have system component failure or power plant or engine failure. By going straight to autonomy, we have an opportunity to eliminate those causes of accidents. With autonomy, the aircraft will not lose control. We'll have multiple layers of safety. We will have a commercial level of safety baked into this aircraft. And the aircraft is designed from day one around that. It's not like we're bolting onto autonomy onto a piloted operation, that when the autonomy fails, it's the pilot to save the day. The autonomy will always be there. The systems will always be there to intervene. But even if everything does fail, again, we still have that human pilot in the loop, over the loop, who can intervene and do that. So safety is first and foremost, but also scalability. If we really truly want this to be for the masses, how do we get there? And I think it's through autonomy. So safety, scalability, but also economics. And I think with economics, the mission of Wisk is safe, first and foremost, but everyday flight for everyone. We don't want this to be the next helicopter for the uber wealthy. We really want this to be somebody that can take on a daily basis. I live about 45 miles northwest of DC. It would be fantastic to take one of these to and from. I can take the train, I can take the metro, but if I can take something like this on a very defined mission to and from downtown in a seamless manner, that's really the goal. And so if we can do it at a price point that's affordable, similar to what an Uber would be, I think that's really the nirvana and the goal that we can all get to. So safe, everyday flight for everyone. I work up and wake up every day working on some of those policy priorities, which is not a small number, but let's walk through some of those right now. Starting with U.S. leadership. So this was an event that we held back in December at DOT headquarters, where the Secretary unveiled a multi-year effort on a national strategy for advanced air mobility. And it truly will unlock the future of flight. So multiple federal agencies came together and developed a national strategy for advanced air mobility. And in that, in the execution, it had a number of things. And those recommendations from the strategy will not only enable Wisk operations, but Joby, Archer, Beta. And it has, multiple streams of effort: aerospace, infrastructure, security, community planning. I think what we see with EIPP, the ability to get out there and partner with state and local and tribal and territorial partners is really going to be the opportunity that we can really get these aircraft out there. I think Ryan was saying, and not to steal your thunder, but by flying in New York City and showing people that this isn't something that's scary, isn't really futuristic looking, I think people realize, oh, it's actually a lot more simpler than I thought it was, and they get it. Light bulbs go off. Same thing with small UAS. A lot of people think, a package delivery is scary. It's kind of something that's very futuristic. But talking to my friends in that space, one of which is in Arkansas, once you do it and people see the benefit to them, the light bulbs go off. Oh, I can get something delivered to my door in an hour. I get that now, and it's applicable to me. It's not applicable to the uber wealthy, and I could see myself now, rather than taking a car or having a loved one drop you off at the airport, now I can just take a Wisk, a Joby, an Archer, or a Beta and save time, do it quietly, economically, and sustainably. But we need the U.S. to engage. We need FAA, we need U.S. government at large, but also international. This is a picture that my colleague Kat took at the Singapore Air Show. So it was fantastic to see the FAA administrator and FAA leadership there showing up, engaging internationally, seeing how we can collaborate, harmonize, develop a strategy that not is only U.S., but allows us to take aircraft that are certificated here and expand that globally, so we don't have to have a different model, a different operating paradigm in these different countries. And what we intend at Wisk to do, and I know several of my friends from other companies do, is we really want to leverage that new eVTOL integration pilot program, or EIPP, that Cliff mentioned. And Wisk went all in on Texas. We put all of our chips into that basket. We have a really strong partner there with the state of Texas DOT, but also a lot of support nationally as well, both on the Senate, on the House side. A lot of focus, a lot of interest, and a lot of good work that they're doing in the small UAS space. And our involvement in the EIPP is a little bit different than a piloted version. My friends from the other companies, they have a pathway to operations through not only the certification of the aircraft, but because they have a pilot, the Power Lift SFAR could apply to them. The Power Lift SFAR does not apply to them. The only path that I have for commercial operations would be through Part 11 and do a litany of exemption requests, which is a long and risky endeavor. So if I have an ability through EIPP for the FAA to provide those waivers and those approvals, and we can get up and running, we can go learn and do in a seamless and streamlined manner, that's our plan. So really build upon that opportunity to gain that flight experience and inform those future rules, those future policies that will enable our operation to really get up and running and scaling through that operations. In parallel, though, we're going to unlock some future technologies, and I think really see the opportunity through the Center of Advanced Aviation Technologies, or the CAT, which is also in Texas, to really leverage some of the stuff that we're working not only with Wisk, but also one of our subsidiaries, SkyGrid, a third-party service provider. But we need those clear and defined pathways for not only the certification of the aircraft, but also the operations. And so we're definitely going to leverage existing frameworks, existing rules that work today. But there are gaps, and we know there are gaps. And the FAA's identified those gaps for us, which was great. We actually worked through another association called General Aviation Manufacturers Association in DC, or GAMA, where the FAA held a number of workshops last year. And they sat down with us and our partners, and they worked through what are the gaps that they know that are around the current regulatory structures and policies that would unlock and enable autonomy and enable autonomous operations, workforce, infrastructure, airworthiness. And there are a number. And I think we could, at one point, there was talks of, well, let's stand up an aviation rulemaking committee, which I've been, and maybe several of you have been as well. And ARCs are fantastic, and ARAC is fantastic as well. But those are also venues in which we all just sit around a table and we discuss. If we now through EIPP have an opportunity to go do and actual operate and inform these gaps through operation and actual data, that's a gold mine. And so we intend to take full advantage of that. Pilot workforce, was real quick on that. Over the last 12 years, one of the things I've been involved in is leading the FAA's Aviation Rulemaking Advisory Committee, and under it, its Airman Certification System Working Group. So Cliff mentioned the ACS, and we had a big effort to, when they decided to go 2117B and enable powered lift for not only Leonardo, but also advanced air mobility. We had a big effort to get the standards in place, the guidance. We worked hard to get those up and running, so those are out, but to Cliff's point and Leonardo's as well, they probably need a little bit of refinement. And so with that, I'm hoping that the FAA stands back that group up, because we see that industry collaboration with the FAA is really key. And as we get new entrants, as we get something like Wisk, where I have a remote supervisor who is operating, yes, I can take an existing helicopter pilot or an airplane pilot, and I could run him or her through a training program to be our multi-vehicle supervisor or remote pilot. But if we have an opportunity in the future to define a new standard, a new certification under Part 61, maybe leveraging what we've done with small UAS and kind of up-level that, so we can really clearly define what a person needs to know, consider, and do to be one of our operators or an autonomous operation, that's really the opportunity, and I think we should take advantage of that. To wrap up, though, so a couple weeks ago we had modernizing, I think, aviation summit at DOT headquarters, where the secretary met and presented some of the stuff that they are working on, the brand new air traffic control system and modernizing our air traffic services, which is a great opportunity. I loved the control tower identifier. I think, well, maybe that's going to be coming and changing PVIs here in the near future, but we'll see. But the secretary really highlighted, hey, we have an opportunity, and they're doing great work on modernizing our airspace. They have, it's funny, because a lot of the issues that they are working to solve have been known issues for so long, and yet we just never had an administration that really leaned in and got the funding that they needed to really enable that. So now they have the funding, not all of it, but a good down payment, and they're working hard to get that system in place. But in order to take full advantage of that system that's going to be new and modern and digitized, we need to maybe couple that with a new set of flight rules. Today's flight rules have been developed over decades. IFR was, the routes under IFR were designed around beacons, light beacons, even if you had fire pits going to really identify the Victor Airways. We need a set of flight rules that can really take advantage of this new era and take advantage of the technologies that the FAA is instituting. So Boeing, SkyGrid, and Wisk all got together, and we did publish a concept of operations on a new paradigm, automated flight rules. You can do the QR code. It's downloadable. It's a huge document, so for your reading pleasure. But it really defines that new third operating paradigm. Now, we put that out for feedback, for input. We fully recognize that this will be an iterative process. We want this to be applicable to not only advanced air mobility, autonomy, piloted, but also legacy operations, helicopters, GA pilots. And I think, taking advantage of what we're doing for the brand new air traffic control system, or the BNATs, really is the opportunity that we should not waste. In parallel and complementing that concept of operations, Wisk and SkyGrid did do a white paper that really focuses on enabling scalable UAM through automated flight rules. And I think, it's clear to say, it's fair to say that, autonomy is in everyone's roadmap. It's just when we get there. And I think, if we can enable that in a safe manner that's standardized through a new construct like AFR, that's really the key. Overarching strategy, the vision, though, is really moving beyond VFR or IFR. As an aircraft that does not have a pilot on board, I will most likely have to utilize instrument flight rules, which is a little clunky, a little heavy-handed, and if you have a fully capable aircraft that truly is autonomous, maybe it's somewhere in between the two flight rules. But really shifting from that human in a loop, just the pilot's on board, he or she will save the day, to more of a spread and shared responsibility throughout the systems, not only on board, but also on the ground, and then people on the ground as well. But it also complements a lot of the FAA and existing FAA and NASA frameworks, from infocentric NAS distributed responsibility. I think what they did with Part 108 and sharing that responsibility for, pilot and command duties is something that we should absolutely take advantage of and leverage for future operations, but also scalability. So long-term goal, obviously, fully integrate autonomous operations, but not only one-to-one, but one-to-many, to really get to that price point and that safe point that we can allow this operation to really, truly be for everyone. Appreciate the time. Look forward to the conversation after, but thanks for the time.
All right, our last speaker before we go into the panel, so please save your questions for the panel. We'll have a lively discussion, is Ryan Naru. So quick intro, he's been with Joby for the last 5.5 years, where he is the aviation policy and regulatory affairs lead. He was previously a regulatory affairs specialist at Uber Elevate, which was acquired by Joby in 2020. That's it.
Well, thank you, everyone. And in an effort to get to the lively Q&A and panel discussion, I'm going to keep it pretty short here today and rely mostly on our verbal communication instead of slides. But I do want to take a second at the beginning to also acknowledge there's a broader Leonardo team here present today. I had the opportunity to be one of the non-pilot participants in the familiarization track, as opposed to the formal 7-hour evaluation track. And I can tell you, fatigue management, I can see as one of the outputs, I might have been one of the ones who responded that I was fatigued. But I can tell you that going between so many different systems and doing it so well, the team that executed on that activity were so professional, so well prepared. The equipment was right-sized to the task. It was just a really impressive take at a whole organization that was motivated by learning, right? And then bringing that forward to the community. So hats off to all you guys. Well done. Very excited to move into phase 2 with you all. And then we'll have to bring David along the way as well, even though he doesn't have a pilot station in his aircraft. I know he'll be really excited to contribute next time in Milan. So, and same with Cliff. So with that, I do want to just take a minute to kind of speak about the moment that we're at right now in our industry. And I know, like, every time that we get up on stage, we talk about the milestones and the inflection points and how transformative things are going to be. I'll just spend a second personally reflecting, though, on the fact that I do think that Joby's operations in New York City, as well as in the San Francisco Bay Area to the Oakland International Airport, did move the ball forward, not just for Joby, but I think for the whole industry across a lot of axes. And so I just wanted to spend a couple of minutes to provide some verbal remarks on that, and then we'll bring that conversation into the Q&A. I think first and foremost is with respect to aerospace integration. So in October of last year, the FAA published an update to Order 711065. This is the air traffic control policy guidance that essentially establishes the phraseology, the separation standards, all of the how in operations to manage our airspace safely and effectively lives in the 711065 and its amendments. And in that document in October, powered lift, the new category of aircraft that's now being internationally recognized as a distinct category, was put together with helicopters as the same phraseology, the same procedures, the same separation guidance was to be applied by controllers to a powered lift as is being applied today to helicopters. And I think that that is a reflection not just of the national strategy, but also of the operational learnings that have come along with years and years of hard work and effort to actually demonstrate the capabilities of these aircraft and to execute on sort of the first round of validation. And by the way, I do want to acknowledge the AW609 has been operating in the NAS to controlled airports for a very long time. So we are not the first powered lift to have done it, but we are the first electric powered lift to have done it. And So what Joby did was, following the October release of that guidance, we began operations on sort of an increasing cadence of, let's just say, complexity, right? An increased amount of involvement, increased numbers of lines of business within FAA getting involved and aware and learning from the activities, starting with operations to Class C Monterey, which is a little bit of a sleepy Class C. I put it actually a little bit more in my Class D bucket alongside Salinas, which is the airport immediately adjacent to our flight test facility in Marina, California, both Monterey and Salinas being our neighboring airports. And so being able to exercise those air traffic control procedures at those two facilities as a starting point then allowed us to then begin planning an exercise up to the San Francisco Bay Area to Oakland International Airport, another Class C facility. And I will tell you that the integration challenge there was certainly like that next level up, right? We have a much higher volume of traffic, not just from Oakland itself and its commercial jet, regional jet, private jet traffic, a very significant GA population of aircraft there, and also the intersection with all of the SFO traffic just across the bay. And so really demonstrating our airspace integration capability with the aircraft to fit in just with all the other helicopters into the same operating environment was a key step forward. Took a lot of planning and a lot of hearts and minds, right? To, yes, this is exactly how we understand they operate. Yes, this will be in the exact same areas. Yes, we'll be communicating the same way. Yes, we'll be handling failures in a very, very similar, if not identical way. Okay, let's go try it. Let's go fly it. And that's what we did recently in the San Francisco Bay Area. We took then that momentum and carried it forward into New York City, adding on new operational complexities. So in the interim between the San Francisco operation and the New York operation, we had a new GNOT, a general notice come out, which amends that 711065 air traffic control guidance that I told you about, eliminating visual separation as a primary separation means for helicopters in airport environments with respect to takeoff and landing routes. And there's the GNOT language itself is actually pretty high level, and there were significant interpretation challenges by controllers across the NAS. VAI was instrumental in helping to resolve. There was a number of safety review meetings that happened, and I think that things have normalized again. But Joby, having acquired Blade Technologies, essentially an indirect air carrier providing air transportation services on helicopters through partner 135 operators in the New York City region and around the world, gave us really a front row seat to everything that was happening, right, in these complex airport environments, Newark, JFK, LaGuardia, et cetera, with respect to helicopter integration. It allowed us to be able to speak from a future-focused perspective as well, talking about the new technologies that are going to enable procedural deconfliction, the ADS-B in and out expectations that should be had for the traffic operating in those complex areas, et cetera. We also added complexity that we were operating to 3 Manhattan heliports. And so I think that, we've talked a lot about vertiport standards and design guidance for the development of new facilities, but this discussion about operation to existing facilities has been a parallel conversation, right? There is a set of design standards for what you're going to do if you're going to plan and develop new aviation infrastructure. That's where the Office of Airports lives and with their guidance and documents. And then there is the rules that actually apply to operators and air carriers when it comes to the utilization of takeoff and landing facilities and what is considered acceptable and adequate. And to be able to utilize this activity to fly to all 3 of the Manhattan heliports, so downtown Manhattan heliport, East 34th Street, and West 30th, showed that in realistic heliport environments, which are not ideal, right, and don't necessarily meet the baseline standards that we have today, number one, we still have tens of thousands of operations a year to each one of these facilities conducted safely, and number two, the Joby aircraft could fit into those environments seamlessly. And there's a couple of different axes to those learnings. And I'm not saying that all the answers were provided or all the data was collected or every scenario was tried. I'm saying that We had an opportunity for our first, I think, very rich source of data collection in a real operating environment in these heliport environments. What are we talking about? Downwash and outwash, as we know, has been a really key focus area within, not eVTOL, within vertical flight globally, right? And we've seen a number of accidents, either the S-92 in the UK and H-60 in Japan, showing us that this is a risk that comes with fatal consequences if it's not managed appropriately. What's been great is that we were able to build off of data collected with the FAA in, I think, 2022 or 23 in Marina, California, to essentially have a first pass view of like what is our outwash of this aircraft, and on a controlling dimension basis found that it was very similar to a light helicopter. I've had the opportunity personally to walk around the helicopter while it's hovering, so I can vouch that what I'm saying there is true, and I'm not just making that up. I've felt it, and it is what you would expect. I mean, it's an aircraft. It's flying. It's right there. Like, it's going to produce outwash. And I think that managing your expectations in an operating environment is something that the UK CIA has been really focused on too. It's not just what is the physical effects present. It is how are you prepared for those effects, and how are you bracing yourself? How are you, or if you have a small child, are you holding their hand? Is the baggage being managed, right? There's lots of different levels of operational safety that go along with it. Our marshals were, within the FATO dimensions, bringing the aircraft in, and you can watch the videos, they're public, they're online, you can see there's really no safety effects from those particular operations. Charging, while we don't have fixed chargers at these heliports just yet, the downtown Manhattan heliport and East Side heliport will be equipped with Joby chargers, Geeks chargers, before the end of the year. So as we talk about the expansion of our operational footprint, particularly in the scope of EIPP, New York City is going to be an area where we will be operating far more frequently, as the infrastructure is going to be set up to allow us to do that repeatedly from those heliports. I think that another area is going to be acoustic performance, and I think that you've seen online, if you've been on Aviation LinkedIn or Twitter lately, you may have also seen some posts from Stop the Chop and our local assembly people from New York, city council members, all who were present at our events, either at downtown Manhattan heliport or the East Side heliport. And in those operations, we did several things. Not only did we transit from JFK to the facility, so which is itself like a very monumental achievement for an eVTOL. We did quiet passes, right? So we fly with a chase aircraft, just kind of part of standard procedure still today. We had the helicopter stay out and away from the demo operation. We did several orbits in wingborne flight, and it was absolutely inaudible in that environment. You'll see folks, I think, who are going to be saying that more and more. One of the assembly members who was next to me said, "That's as quiet as a library." And I was like, yes, please say that on camera. It was truly spectacular to see the engineering effort actually produce a tangible policy outcome in terms of belief related to what the acoustics of these aircraft can achieve in terms of accessibility of the product. In thrust-borne flight, we also had the opportunity for the participants to see the aircraft take off and land, and there were helicopters that took off and landed before and after us, and the difference was stark. Not only just in terms of the noise quality, and when I say that, I speak specifically about like frequencies of sound, so low frequency sounds from helicopters that is percussive and penetrates structures, bodies, right? That is a very noticeable effect, versus a more broadband, higher frequency sound coming off the aircraft that attenuates in the air very quickly, but also the unbelievable effect of shutting down an aircraft after it lands, versus the helicopters that are kind of ever present, keeping their cycles down and the turbines on. There's a really meaningful difference in the lived environment there, especially when your heliports are right next to community parks, waterfront parks, which people really want to utilize and enjoy. As a New Yorker, I personally feel strongly about this one as well. And so I think that as we look towards, the future, there's certainly going to be tons and tons of data to be extracted from these operations and shared with the FAA. Cliff, we're going to have a number of, I think, after-action meetings across the various lines of business, but Office of Airports is going to be one of the focus areas where we talk about our operations at all the heliports. What did we learn? What are we looking to do in the future? Permanent charging going into those sites as well, very exciting. Aerospace integration, there was actually one or two areas that were like unique challenges that we're going to look. We talk about regulatory smoothing in the EIPP. So operations in the East River Corridor are actually regulated per Part 93 as a special flight rules area. And there are regulations that pertain very specifically to airplanes and very specifically to helicopters, but other categories of aircraft, gliders, lighter than air, and powered lift are not regulated according to those rules. And the FAA had an opportunity to make some decisions there when they did the SFAR. They did a comprehensive part-by-part evaluation. They elected not to here. I think that with respect to that environment in particular, minimum safe altitude rules will be an area that I think is going to require further refinement in terms of guidance and if not permanent rulemaking in the SFAR. And I say that because the current language speaks to wing-borne flight mode and thrust-borne flight mode for minimum safe altitudes, visibility, and reserves. They're used differently across the three rules. But for an aircraft like Joby's, where there is no flight modes, that it is a continuously variable state between hovering flight and wing-borne flight that's not immediately transparent to the pilot or the regulator, making sure that there are more appropriate performance-based criteria that do have transparent compliance metrics that can be associated with them, really, I think, important. We elected, because of the LaGuardia crash and because of this ambiguity with respect to some of the minimum safe altitudes and structures along the side of the river, not to operate north of the southern tip of Roosevelt Island, only to enter and exit the SFRA for the purposes of takeoff and landing, and all of that accepted and approved by the FAA. But I think, finding very specific, sharp edges like that are the kinds of things that only happen when you plan real operations with these aircraft in meaningful, commercially relevant environments. So I'm really excited to be able to tell you a little bit about this today. Obviously, this is a presentation that will take more time to do more completely, and hopefully at a VFS event at AirVenture this summer. I know Mike is involved with the Electric Aircraft Symposium. Please see us later, and you'll get the full version of this presentation with multimedia attachments. But it's just been so recent that it's been hard to make sure that we had something super polished for you today. But I do want to also say how grateful I am for all of the partners who helped make the operation possible. And I'll start first and foremost with the FAA. Cliff, you're taking all my FAA gratefulness today. But countless individuals across lines of business making sure their equities were represented, whether it be airspace, infrastructure, flight operations, the airworthiness of the aircraft, you name it, right? Everyone definitely was involved. It was a deeply coordinated event for 2 weeks of operations. And I can tell you, the FAA and I became best friends. We were on the phone every day, multiple times a day. So I'm also grateful for the relief there, but gratitude to the Port Authority of New York and New Jersey, Economic Development Corporation in New York City that operates 2 of the 3 heliports, True Weather, New Air, Vertiports by Atlantic, and Skyports. There you go. So thank you all, and looking forward to the conversation.
Go all with the lapel mics. Ryan, did you get mic'd up? Okay. We don't have hands held, so go take care of that.
Just lead into me.
Where actually are we? Yeah, there you go. Well, great. Thank you all for staying. We only have 20 minutes for Q&A, but I have a ton of questions. Many of you may have questions. This should be an interactive discussion. Also, our panelists are allowed to ask each other questions, so feel free to do that. I want to start with you, Cliff, though. I want to ask you about harmonization. You mentioned, going through the pilot handbook, the Rotorcraft pilot handbook, and needs to be updates. So Cliff co-chairs what used to be the Vertical Aviation Safety Team Technology Working Group, which I started with Cliff. Now Rex Alexander in the back, who's going to ask a lot of questions about infrastructure in a minute. But it's a group, working group with the FAA, EASA, and others, and it's been really illuminating. So can you talk about what's going on with the harmonization in general, but specifically the Rotorcraft pilot handbook?
Sure. So I think one of the great things that Mike mentioned is the fact that we do have these pathways and these channels to collaborate, and this is one of those. And that working group in particular has been great because there's been a lot of interaction between the FAA, EASA, and our industry counterparts. So Leonardo's on there, Andrea's on there from your shop. We've had other OEMs, we've had technology companies, different folks on there. And what we've recognized is that these are not just FAA problems or EASA problems. These are worldwide issues and things. And we're looking at, okay, when we make a revision to the helicopter flying handbook, which we know is out there. I'll give you two examples. One is with the Bouchard recovery technique, and that had spawned, even though it's in the flying handbook right now, it had spawned some discussion about the studies we were doing because of the accidents on Vortex Ring State and others around the world were doing. That spawned sort of an impetus on, let's compare these recovery techniques, and then let's look at things where Airbus is doing something with the power-assisted recovery. So how do we involve the other OEMs and everything to that? So that has kind of grown and morphed into a platform where we had the VRS workshop on Monday here at VFS, and VFS is a great conduit for doing all these things. And that led to more discussions there. That's leading to changes that the FAA is going to make on some of these things as we vet that and we understand the data and the recommendations coming from industry. And that's just one example, I think, of things. And I think there's numerous other ones as you go through it. And I think the path is really, it doesn't have as much weight to it if it's just coming from one entity. But when the industry really gets together and can work collaboratively with the regulators in a kind of formal and informal settings like VFS and others, then that really blazes the trail for where we all want to go with this.
Very good. And as you mentioned, lots of different, there was a discussion on Monday, downwash and outwash, VRS, and I think those kinds of discussions will be a bigger part of VFS going forward. And then from the as you mentioned, from the regulatory perspective, you've got Gamma, you've got VAI, and others that are also advanced and involved. But you guys are all invited to comment on, what is VFS, what value does VFS bring, has been bringing, and also what areas could VFS add in the future. So sorry. So let me go over now to Ryan. It was good to hear that you were saying that it was, inaudible, like a library. I've been in New York City. Many of you have been. It is a noisy city. It is hard to hear anything over that. So I know that was one of the things from the original, Joby, and then Uber elevators, hiding in or not being audible over the noise of the city. So it's good to see organizations like Stop the Chop, who have been trying and successfully getting rid of helicopter flights in New York, realizing or commenting on that. So that's just really, really great to see. So I got a couple questions from people about Joby. How did you get over, and I know the answer to this, how did you get over, flying experimental aircraft over people?
Well, I think, so first of all, we didn't, which is
Exactly.
great. I think that, if you studied the flight paths that we took through the entire program, whether it be in San Francisco, Oakland, or the New York metropolitan area, we were always over water. We were operating according to our exhibition airworthiness, so very standard. This was not an EIPP flight. There was no special authorities or waivers or exemptions or deviations issued in order for us to operate. And I think that speaks strongly to the support that the experimental aircraft industry has, right, from the FAA. Writ large, those authorities are growing and expanding, as we spoke about with respect to Mosaic. And so I think it was a very pragmatic management of risk, right, by the FAA to have appropriate limitations on where we could fly, right? We're not going to go screaming over Brooklyn on our first go, as much as I wanted to. And I think that, that was a really appropriate set of mitigations. And I think that over time, right, what is the EIPP program going to be about? It's what are the kinds of operations that we wouldn't normally be able to do, let's say, as an experimental aircraft, in a pre-type certification environment. And with Mosaic, for example, now increasing the authorities of the FAA to enable experimental operations over people, you might be able to have more realistic routings, for example, of the aircraft from JFK to New York City occurring on the park route, conduit route over Brooklyn, once an appropriate level of safety can be demonstrated either from the aircraft's production system, the level of developmental flight test or showing of compliance right across the flight envelope, et cetera, et cetera. So as we move closer and closer to TIA, I expect the willingness to enable certain types of additionally complex operations will expand. What does that actually mean for Joby? Like, why do we care about all this, right? Like, what's the big deal? If I was to have my type certificate today, and what a great day that would be, you're invited to the party, all of you. But the challenge would be that there's a significant period of time between type certification and initial operational readiness for a commercial air carrier that, can, on a good day, take a short amount of time with a conventional aircraft, and I expect with an aircraft like ours to be a year plus of activities, right, in terms of manual development and acceptance, training program operations, right, which includes not just the type rating, but also the scenario-based training in market, right, mission-specific prohibitionary flying, right, where you have mentors taking newly minted type-rated pilots into JFK for the first time, right? All the operational suitability work, route provings, et cetera, those are the kinds of activities that you don't necessarily need to have a fully TC'd aircraft to begin burning down regulatory risk on, so long as appropriate mitigations are placed on the operation. And I think that what we see today out of our market survey frameworks is just another one of those paths along the road, right, where you get to do more and more and more with an experimental aircraft as it gets closer and closer to its maturity gates to full TC and full commercial ops. Legally, I'm sorry, you're gonna have to cut me off, but legally, EIPP does enable pre-TC commercial operations, but I expect that the bar will be very high, right? That is gonna be the end of a long series of operational and regulatory escalations to enable anything like that, and I expect that there's going to be a significant amount of customer transparency that's going to be required, which means that the kinds of missions that you might see, from my perspective, optimistically, on terms of commercial pre-TC, if there's going to be anything, probably your Hudson River air tours, right? Up and down, you have plenty of time with the potential user of the product to explain what it is, how it's different from the other vehicles that are on site, the types of enhanced oversight that's available, but still the liability that you might be taking and doing it. But there's enough people who really want to be first in the world. I had to start beating people away from the aircraft when we were flying in New York. Everyone wants to jump in. So I think that there's going to be an exciting world where these sorts of things are possible, and possibly for us before the end of the year.
Very good, and it definitely is exciting, both your New York flight demonstrations and Wisk with the now having 2 aircraft in the air. Let me come back a little bit. Sorry, I want to come back to Matteo also and ask about the SFAR and piloting and the EIPP. I got a whole bunch of questions here. So in, I think it was 2024, they published the final special Federal Aviation Regulations, SFAR, which doesn't mean anything, but it's the SFAR for powered lift operations. And it was 880 pages or whatever. My name is in there because I wrote something, and so it was, very in-depth. And to just give you a bit of perspective, in I think 1996, when Bell and Boeing came out with the BB609, which now is a Leonardo AW609, it's generally agreed that they're going to use powered lift. They developed powered lift in the 90s. It was going to be, perfect for a tilt rotor. But they only published the operational rules in 2024, so 30 years later. So I guess, Matteo, for you first, so finally they had this. So did that solve all the problems for Leonardo, and are you guys now have a clear path, you're marching forward to certification of your aircraft?
No. Let me say straight no. But at least it does exist. Okay, so I think the good news, to be pragmatical, is that you got a reference, which is at least a starting point. But the thing we found was that the overarching logic seems to be that when you teach somebody to fly we know a tilt rotor is kind of power lift, of course. It's like telling an airplane pilot not to be scared of below stall speed because you're not going to fall out of the sky. And you need to teach a bloody helicopter pilot to follow the bloody procedures, which is not exactly in the DNA of pilot. The problem was that it implied a sum of two syllables. So the thing becomes unaffordable. It takes forever. And even if you alleviate it with simulation, all right, but it's not serving the cause. So we were really happy that it does exist. So we have a starting point. But if you think about the adequacy with respect to what we're trying to solve, not to the point. The other point is that the lift cruiser and the tilt rotor, the mechanics, flight physics are not the same. So the way you teach, the things you need to look at, the overall behaviors of the aircraft and the interaction with the aircraft is different. Even if you make it, if you want, simplified and you enhance the systems, the level of awareness that you need to do about the flight physics is different. So that's why I said a straight no, not to be, if you want, offensive, but simply because we need to do the next step. And pretty fast, and maybe less than 30 years.
For sure. And
it's no secret, by the way, that we agree, and that I agree. I say it like I'm 99% happy with the SFAR, and that the 1% is like, actually where the devil is in the details, of course. It's in our public comments, so this is not breaking news. I find that the fundamental premise of putting these aircraft together in a category is flawed from a safety perspective, that it is flawed. Because the categorization is happening based on the external characteristics of the aircraft. What is the aircraft capable of doing, right? It flies to heliports, it can fly like an airplane, it can fly fast, okay. In today's modern cockpit, the human-machine interface is what matters. Right? And this is the conversation that Leonardo's leading, that you don't have to have, but it will be for your operators.
It will.
But in a world where you take the existing category-based system for training and qualifying and checking airmen, the powered lift instrument rating creates safety risk. It creates an incentive for pilots to come to Joby, to Archer, to Vertical, et cetera, to gain the time in a cheaper platform, to gain their instrument rating, and then go to whoever's operating the 609 and leverage that certificate. And there's nothing about the framework that keeps you from doing that. And so our point all along, and it will continue to be throughout the SFAR, and I'm hoping to file off that sharp edge, is to say the rest of the world, which is following ICAO, has gotten this right. You need to follow a type-specific approach. You can't call the type rating the cure-all without putting all the safety eggs in that basket. And so my perspective remains, and it will continue to remain, that it's a type-specific approach, a type rating on an existing airplane or helicopter certificate. Those curricula will be different. Joby's experience is that with an airplane-centric human-machine interface, and this is our experience going all the way to the VOC carrier with program expertise that's carried forward from VOC carrier to F-35 to Joby, is that a person who has rotorcraft recency and fluency has a reversion to type issue, right? Where, if you wanted to go forward, you might have been commanding down, right? Because it's dark and it's raining and you want to get back onto the deck, and what do? You went back to your helicopter thing instead of your airplane adjacent flight control item. So there's a different emphasis for what a rotorcraft pilot, I know, I'm sorry, time. But so I believe very strongly in this. We have to fix it. We have to follow ICAO. There will be convergence, as Leonardo is demonstrating, around certain configurations that are unified or unified adjacent. And Mosaic is going to push this conversation even harder as simplified vehicle operations in regular airplanes, regular helicopters on the outside begin to, again, challenge this logic that our certificates need to be based on what the aircraft is versus what we are expected to do as pilots.
Can I add one quick thing? So fully support, but I think what we should do, and hopefully the FAA is thinking this way, is as we've enabled things, the SFAR is supposed to be a time-limited rule. It's supposed to be. It just is.
10 years.
And that's what we have SFARs. Now, some SFARs have been around forever, but we should take the experience under the SFAR. We should take the experience under EIPP in these 8 awardees that have, all of that will generate copious amounts of data. Joby's going to do a bunch of data from their SFAR. And then we have the CAT, the Center of Advanced Aviation Technology. I am hopeful that we take all of those operations and all that data feeding into a rulemaking effort to refine the SFAR, to establish my pathway. SFAR doesn't apply to Wisk, so what is my ultimate approval? To maybe certificate third-party service providers like SkyGrid. And I'm hoping that all of those streams factor into that, so at the end, we get into a final rule, and they would publish an NPRM along the way, so that we get to that final rule, so that when EIPP is over, it goes right into that final rule. So we don't have to have this gap window of like, EIPP goes away, your waivers go away, my waivers go away, now we don't know where to operate.
Starting from scratch.
And this is exactly what's happening, by the way. So the FAA's flight standards offices have begun thinking about all of those bridging mechanisms, right? With the ultimate objective being refine the SFAR, get to general rulemaking, right? That's time limited. There's going to be waivers that are available to EIPP participants that are not exemptions. That'll take much less time to work through, but they are coupled with a regulatory learning need from the FAA. They're not just magic wand waivers. You have to, here's an issue that we need to work through together. Here's why we think this alternative proposal is equivalently safe. Here is the set of validating flights that we're going to conduct to collect evidence. Here's how we're going to review that evidence. And in parallel to that waiver, we'll probably live a draft
NPRM?
No,
AC?
no, I'm sorry, when you're trying to, with an
Exemption?
E. Thank you.
We don't want exemptions.
No, but the exemption will be ideally like something that comes, from the EIPP knowledge gathering. So that way, when we're in full TC 135 service, it's there, it's available, and then it can transition into the framework for future general rulemaking, right? Which is how we do our rulemaking today. We start with our exemptions or special conditions, and then we see where can we find commonality.
But we should inform that rulemaking through operations versus let's go sit in a room and talk about an ARC
and I think
report.
I think just real quick, and get back to Mike, but I think it's a continuum. I think what you guys are all saying is correct, and I think in my experience, right, it is always, you can, as much as I love and, you know, have a lab, you guys have labs and everything, right, and I love doing lab work, I love doing simulation modeling and all that other stuff, but you have to go out there, you have to operationally test. And I think what really will happen is you do all that, all the skills, all the capabilities, all the things that you're mentioning, they come to light, and you understand different problems in a new light. And then it's just a matter of taking all those skills and understanding that we need to move more towards maybe a competency-based approach. You know, I mentioned that before. So what do we need to do to take all of that information, understand what really is the best path forward, considering safety? And some of it is also, you guys mentioned it, right? It's educating others within our workforces, whether it's on the FAA or the EASA side, so that we arm that inspector or that POI or that person out there with the knowledge so that they know when they're approving an operation that they're doing it and they're not making a guess and they're not being too conservative or too lenient.
Spot on.
Great. Well, we've accidentally exceeded all of our time. Great discussion. That was priceless. So thank you all for coming. I did want to mention Ryan Naru mentioned Oshkosh. So the Electric Aircraft Symposium, VFS is organizing the 20th annual EAS Electric Aircraft Symposium at Oshkosh, and Ryan and Tom Gunnarsson from Wisk will be speaking, as well as 35 other people on electric aircraft. So right now it's lunch break. I believe it's we reconvene at 1:30.
1:30.
I'm also chairing that session, which will be on propulsion and power. So I encourage you. It's lunch on your own. There's some great restaurants across the street, wherever direction that is. So please, this way. Thank you. So 1:45. Excellent. So you have an hour and a half to come back here. And yeah, thank you so much for coming in. Another round for our super panelists here.